All right, so my name is Lucas. You'll get to know me during the day. With me, I have Angel. I'm an application engineer at Mathworks. I basically work with universities and research institutes, trying to help them for correct adoption of Mathworks tools. And with me, Angel, he's the responsible for the education business in Spain and Portugal. So if you have any sales-oriented question, he's your guy. If you have any technical question, you can ask me. All right, so let's see what's the objectives for today. And the goal in today's machine learning for computer vision presentation is for you to get exposition to examples that solve real-world problems, so that you can see how MATLAB simplifies the machine learning workflow, so that we can go from an idea to a prototype very quickly, and that you improve your productivity. Really the goal is for you to see that you should expend less time coding and more time producing, right? So this is one of the goals behind MATLAB today. Hopefully, you will also learn some new things about machine learning, image processing, and computer vision. So the audience today I assume is going to be a tough one, because you guys know a lot of computer vision, probably a lot more than I do. So hopefully I can teach you one or two new things using MATLAB. And regarding questions, we will have some time at the end, but if there is any related question that you might have during the presentation, just please raise your hand and you can ask it. All right, here's the agenda I'm going to follow. I'm going to start with a very quick introduction to see what kind of applications we can solve. We will look at the machine learning workflow that I envision personally at Mathworks, and we will discuss some common challenges that you might face when you do machine learning, whether that's for computer vision or other applications. And then most of my presentation is going to be on MATLAB, so we're going to look at demonstrations. I'm assuming 95% of the presentation is going to be MATLAB based. So we will take a look into object recognition using live video. We will go into training object detectors, some clustering techniques, and then we will wrap up and open it up for Q&A. All right, I would just for a second, I would like to take the temperature of the room. So how many of you use or have used MATLAB before? Okay. Okay, and how many of you use MATLAB for computer vision today? All right, hopefully we'll get a few more friends during the session. All right, so what kind of problems can you solve using computer vision with MATLAB? Well, there's a lot. To start with, object detection is getting more and more used in our daily lives. Today, almost every smartphone has an app, a camera app, that will detect your face when you're about to take a picture. Also, advanced driving assistance systems in cars help detecting pedestrians and cross signs and cyclists. There's also object recognition or classification. It's becoming increasingly popular. Our social networks like Facebook or Google+ use it to tag our friends. And this is a very popular machine learning technique as well. Also, clustering, it's a very common machine learning technique. And one of the most common clustering algorithms is actually segmentation, where you try to group similar looking parts of an image, like in this medical image. Also, when you have a very high volume of images, you might want to do some pre-processing technique and to group images that look alike or that have some similarity. All right, so when I was preparing this talk, I thought I should introduce machine learning. And if you go out to the internet and you search for machine learning, you can find as many different definitions of machine learning as you can look for. So I thought I will create my own machine learning definition. And I tried to stick very basic, so I thought a good way of defining machine learning would be that machine learning uses data and produces a program to perform a certain task. So with that, if the task I'm assigned is doing, for example, image category recognition, we could start in a very simple way by just taking a group of images, let's say boats, coffee mugs, and hats. And I can start writing a very simple program using if-else statements and trying to make use of different properties that these images might have. But as my program becomes larger and larger and I get more and more and more images, it's going to get very difficult to maintain this program. And this is where machine learning techniques come in handy. So the goal is, instead of taking the approach on the left, we can just take our training data, which is going to be this set of pictures of boats, mugs, and hats. We're going to run this through a computer vision algorithm that basically will help us to disseminate important information that these images might have. Then we'll run this through a machine learning algorithm and will help us to classify boats, mugs, and hats. So the workflow using images and machine learning with MATLAB is going to be basically we start with some training data. Once we get this training data, we're going to perform something that you're all familiar with, I assume, which is some sort of feature extraction. We're going to extract discriminative information from the images. We're going to run this through a learner or a model. And basically, we're going to get our classifier. And this whole process on the top is called the training step. Then at some point, somebody will provide us with an image that the algorithm has not seen before. And so we have our input image. We will perform the same feature extraction as we did in the training step. We run the extraction through our classifier, and the classifier says, hey, this is a hat. Okay? And this is our classification step. So I see three different challenges when trying to accomplish this workflow using MATLAB and probably using other tools as well. So the three challenges for me are first, having a good way to import large sets of data. If we use a very small set amount of data, this process is probably not going to work. So that's my first challenge. Second challenge is regarding the feature extraction techniques. We will need to figure out why some features are more discriminative than others and why use ones versus others. And then the third challenge I see is in how to find a good classifier. All right, so these are the three challenges we envision. And with that, let's move into MATLAB to see how we can solve this, right? Just gonna try to make some room in here. All right, sorry for that. Okay. So I'm back now in MATLAB. I'm assuming you're mostly familiar with MATLAB. But one of the things I want to do is create an object recognition program. So I'm going to start my webcam here. All right, so I have a webcam around here, so you can probably see what I'm showing there. And the algorithm that I would like to program is basically an algorithm that will recognize my basketball players, right? So when I was preparing this presentation, I had to go back to my mom's house and see what toys I had back in the past. So as you can see, I'm a fan of NBA. And so I'll introduce this to you, although most are familiar. So that's Michael Jordan, Larry Bird from the Celtics, Magic Johnson, and Dominique Wilkins. So I would like to create an algorithm that will recognize Jordan when Jordan appears in the picture, Bird, Wilkins, and Johnson, right? So let's delete the webcam object for now. And this is basically how the demo is going to look like in a couple of minutes. So I'm going to show you the end result for a second. So basically I have a lot of training data, and I'll show you how that training data looks like. Here's just a quick inspection to the data. And I have trained a classifier to distinguish between these 4 objects. So as I run my classifier, this is what it looks like. Let me make it full screen. All right, so you see on the bottom part, I'm not just going to show anything yet, but you see in the bottom part that there's a classification score. All right, so that's going to just tell me basically which is the label or which is the class of the object that I'm showing. So as I go through my objects, that would be Bird or Jordan, I don't know, Bird it seems. That's Jordan, that would be Johnson, so and that would be Wilkins. And probably we'll have to fix a little bit during the demo the way in which this is being recognized. But it's doing a pretty good job, all right? So let me ask you one question and see if anybody wants to answer that. If you were to do an object recognition algorithm, how would you do it? Anyone wants to say something? Okay, I'll answer it for you. 95% of the time, the answer I get is using color. Okay, although with your, in this case, I might get a different answer, but I'm going to stick with the usual answer I get. So I'm going to start using color, see how that does, okay? So if I were to use color, let's go through this MATLAB script for a second. The first problem I face, the first challenge, if you remember correctly, is being able to do all the training, right? Being able to handle a very large amount of data. So before the presentation, back when I was in the office, I captured a lot of data from all the 4 players. So you see here I have different folders for Bird, Johnson, Jordan, and Wilkins. And for each one of them, I have a lot of pictures. All right, so I have already taken a lot of pictures. How can I import this into MATLAB, right? So the great thing about MATLAB is that it has a lot of functions that facilitate the tasks, these cumbersome tasks for me. So first, what I can do is I can use this object, this class, which is called ImageSet. And basically what I do is I just provide to MATLAB the folder where the data is being stored, and I tell MATLAB to look recursively into that folder. So with just this instruction, I'm able to load all the data at once, and I basically end up with an ImageSet array of 1 by 4 elements. And as you can imagine, if I type IMSet of 1, this is basically the first data set, which corresponds to Larry Bird. If I type the second one, I get the different one, and so on and so forth. I can very quickly inspect the number of images that I have for each one of the basketball players. And you see I have Bird, Johnson, Jordan, and Wilkins. I have around roughly 300 images for each one of them. I can display a sampling of these images very quickly. And so if I choose Bird, this is what I get. These are the type of images I took at the time. trying to look for different conditions of illumination and so on and so forth. Right. Now it comes the phase where, all right, I've overcome the first challenge, which was trying to load the data. And I need to visualize the features. But before I do that, I want to show you something about image set, which is really interesting. And that is the fact that image set, being a MATLAB object, it's a MATLAB class, we can use methods that we already programmed at Mathworks for this class. So I can look for the methods of the IMSet object. And you see that I have methods for reading and for making a partition of the object, which is pretty handy when you do machine learning. So if I were just to take Larry Bird's data, which is just the first element of the array, and I would like to partition the data into training and testing for my machine learning algorithm, I'm just going to use the partition method right here. So I'm just going to type training, comma, test, partition, bird, and then I'm going to use 50% of the data for training, 50% of data for testing, although that's probably not very appropriate, but for the purpose of the example, it's good enough. And we see that automatically I get 158 images for training, 157 images for testing. Okay? So the goal here is there's a lot that we have already done so that you don't have to spend time doing this stuff. All right? All right, let's look into the features. So I have to extract features, and so I assume that everybody knows what features are, but let's go for just a second to MATLAB. So what are the features? So basically, features can be seen often as representations of the image. So these representations are often invariant to changes in scale, rotation, illumination, and there are different kind of features. So this is a very simple spectrum of features. So if I look into the densest form of features, those are probably the pixels. If I can also use, for example, color-based features in the extraction. If I look to the second on the right-hand side, I see the hog features. I'm not sure if you're familiar with that, but if you look very carefully, you can probably see the shape of the bike in the image. This is a very interesting feature because this feature is completely independent on color, completely independent on illumination, is just dependent on shape. If I look to the very left-hand side, I see the bag of words. Bag of words is a very interesting technique, which I will use at some point during the presentation as well. And it's very interesting because since I'm just using visual bags of words of the images, I can very nicely even recognize the image when only part of it is going to be present. All right, so let's move back to MATLAB. And I'm going to be using, for now, a color feature extractor that I created myself. So the good thing is about MATLAB is that you can very easily create your own feature extraction methods. I'm going to show you how that one looks. And if you see, this is a very simple function which takes an image, and as an output, it provides the red, green, and blue channel histogram of the data. So I'm just creating a histogram feature with 30 elements for the red channel, 30 elements for the green channel, 30 elements for the blue channel. So I end up with a 90 vector feature extraction technique. Okay, so I can run this. This might take a little while because it's going to run through all the different images to extract the features for the entire data set. All right, any comment? You can see here it took 15 seconds to extract the features for all 1,200 images. And now you can see in my workspace that I have color features, a color features variable that takes 1,229 rows, that's the number of images I have, times 90 columns, which is the number of features, right? So each row corresponds to a different image. And also, I have a cell array, which I named labels, that basically has the same rows, the same number of, or the same number of elements as the color features matrix, and it has the label to which each feature vector corresponds to. Great, so for simplicity, I'm just converting this, this array to a table. I'm not sure if you're familiar with the table object and the table data type in MATLAB. It's basically something similar to what a spreadsheet is. So you're able to store in the same variable, you're able to store data and text. So I run that, and I end up with this basketball image data table, which when I open, you'll see I have a lot of features. And if I go to the end, I see that the 91 column is basically the tag or the label of a basketball player. So I've done the feature extraction. Now I need to do some sort of classification technique. Now here it comes when this is quite difficult itself, because you need to find a way in which you can create a classification method, and if you don't like it, you can discard it and try to choose a different one. And if you were to do that in MATLAB from scratch, you will probably have to test multiple different algorithms. And it's going to be very time consuming for you. So what we do instead of that approach is using something called apps. So we have apps at MATLAB as well. You get this with your MATLAB license and your toolboxes. You can also create your own MATLAB apps. And there's an app which corresponds to the statistics and machine learning toolbox, which is the classification learner. So I'm going to open this app, and it's going to become very, very useful for us. So first thing I'm going to do is I'm going to start a new session, and I'm going to load from my workspace the data that I'm going to be working with. You see I have the basketball image data. I have all my features. Here's a preview of the data. And in order to do a good classification technique, I'm going to have to hold out some data for validating that my algorithm does what it should do. So I'm just going to hold out and leave for validation maybe 10% of the data. All right? So with that, I'm going to start my session. And we have a preview of the data. You see that I'm showing here a scatter plot, and I can choose between different features to show on the map. I can compare 1 versus 5. I can compare 1 versus 7. Basically, I can do any comparison I want. And the great thing about this is that very nicely I get a visual inspection of my data without me having to do that. Also, bear in mind that what we have here is so we have 90 feature vector, right? And we have a lot of data. So basically, we have a 90-dimensional hypersurface that we want to classify, right? In order to do that, we can do various things. So we can start selecting the appropriate features. So I have a feature selection method to choose if some of these features should or should not be in the classification algorithm. Or if I'm not very sure about how this works, I can use principal component analysis techniques so that I can try to reduce the amount of features that are being used in the classification method, and find new features that will explain most of the variance in the data. I'm not going to do that for now, but it's something really worth trying. Then in the next step, I can choose between different classification techniques. So I'm going to start with this part. And the great thing about this is that I can just click the classification method and hit train, and in a couple of seconds, boom, I get the result, okay? So as you can see, simple trees is probably not the best classification method, are very unreliable, and I only get 65% accuracy. But it's good that I can very nicely, very quickly take a look at different things. I can look at the confusion matrix. So if you see, the confusion matrix basically tells you the true class versus the predicted class of the algorithm. And so here I can very nicely see that, for example, if you look on the y-axis, Wilkins gets classified correctly as many times as it gets misclassified. So if I were to just classify Wilkins, I would toss a coin and I will get the same result. Yes? But this classification method is really poor, so I can try other things. How about I try other classification techniques? And you see here I have decision trees, discriminant analysis, support vector machines, nearest neighbors, and ensembles. So how about a medium tree? I'm going to try a few. That's 82%. Discriminant analysis, probably not going to work that well. 60%. I like very much support vector machine. I think it's really useful. It's 95%. How about quadratic one? 92%, 99%, sorry. So you see how very nicely, very quickly I can do this. Let's stick with that one for now. And so if I want to export a model, I just hit export. I'm going to export this to my workspace to a variable called train classifier. I'm going to hit OK, and I go back to MATLAB. So right now, all I need to do, let's see if I can make some room here. I can use my object recognize live color function that basically is going to take a snapshot of each image in the webcam, and is going to extract the features and run it through the classifier. If I do that, what we'll expect is that this is probably not going to do a very good classification. And the reason for that, there are a few reasons. So you see that's classified as Jordan, which is not. You see that's classified as Jordan, which is not. And even Jordan gets classified correctly. So 1 out of 3 gets correctly classified. And I kind of expected that because of a few things. The first thing is that illumination conditions here are very different to illumination conditions I had when I was in the office preparing this example. And the other reason is that really color features are not very good discriminative features. So I'm pretty much better using something else. All right, let's close this for now. What I'm going to use is I'm going to use shape features and see if that works a little bit better. Okay, so this script is pretty much the same as the other script. I forgot to mention that after the session we will send the organizers all the PDFs and all the slides, all the algorithms that we use as well, so that you can download them and play with them as well. So this, as I was saying, this example is pretty much the same as the previous one. So I'm going to quickly go through it. You see here is the montage of the images we showed earlier. Let's see if I don't forget anything. All right, good. And what I'm going to do here is I'm going to do a feature extraction technique using something called bag of words, which is probably something that you already know about. But you'll see how that works in MATLAB. And I'm going to start running that. And while it runs, I'm just going to go back to the presentation for a second and talk a little bit about this bag of words. So imagine you have access to the internet and you look for image processing toolbox in Mathworks website. And if you do that, the text that you're going to get is probably this one. All right, so it tells what image processing toolbox does and kind of techniques that you can use. Sorry. And pretty much what you see is that there are many words that get repeated over and over. Image gets repeated a lot, analysis, and so on and so forth. So if you were to create a cloud of the words and highlight their importance in the text, you will get something like this. So image appears a lot, and processing, functions, and so on. So if we bring this to machine learning, our class is going to be image processing toolbox, our label. Then the training data is going to be our text, right? And then the cloud, the word cloud, is going to be our vocabulary. It's going to be our bag of words. If we bring this to images, we can think of a bag of visual words as the following. We have images of mugs, right? So we have mugs as a class. So we have a lot of different images of mugs. And we can think of the word cloud of these mugs as the handle of the mug, the top of the mug, the body, the bottom part of the mug. So different components. So mugs is our class, it's our label. We have our training data, which are the images, and we have our vocabulary, which is basically a bag of words. Okay, one important thing is bag of words. The algorithm itself uses grayscale imagery. Well, this is just the images that I had, so just bear in mind that this is using grayscale. All right, so how are we going to work? We're going to start with some training data, and we're going to learn a visual vocabulary. So that when we have an unseen image, we do the same feature extraction technique. We basically count the number of occurrences of the input image in the bag of words. We run this through the classifier and we get a hat. All right, so go back into MATLAB. So this has finished already. As you can see, what I use is a function called bag of features with a size vocabulary of 150. And then I encoded the images to get basically an object, or in this case, it's a matrix that is almost 1,229 rows times 150 columns. So I have 150 feature vector for each image. If I want to visualize the features, I can just run this very quickly, and you see how well I have different word counts for each of the images. And the great thing is that these are all pretty distinct, and hopefully I can very nicely segment using this information. So the next thing is, since I already have the features, I'm just going to do it as I did before. I'm going to create a table, and I'm going to open my classification learner app that I had before. I'm going to start a new session by importing the new data. I'm going to hold out again 10% of the data to remain consistent, and I'm going to start again. Now, what should I do? Maybe, I'm just going to start with the basics, which is I'm going to just do the same algorithms I did before. So as you can see very quickly, I can try different techniques. So linear discriminant analysis is already doing very well. Linear SVM, 99. Okay, that's very good. How about quadratic? And you can really use a few of these before sticking to one. So since these two provide the same answer, and I'm a pretty basic person, I'm just going to go for linear. Okay. You see the confusion matrix is pretty good, so only one image gets misclassified, which is pretty great. And then I'm going to export the model, and I'm going to hit OK to export the function, or the object in this case. And finally, all I need to do is run the, hold on, oh, I have a 1 here. Okay. And if I make some room, all right, so here I have again the players, and I'm just going to go very quickly, but basically, well, this is Wilkins. That would be, again, I might have to tweak it a little bit. How about the other side? All right, that's better. Same issue here. That gets correctly, and that one pretty much the same. All right. Oh, this autofocus is not working very well. Okay. There you go. So there's another important thing that is you see the classification score. This is not absolute. So as you can see, when I show, for example, only just 2 players, so this is just getting the most important features in this image, and probably Bird is winning there. And as I move closer to the right-hand side, you see that Bird gets distinguished better and better and better, and hopefully that's doing the job right. Okay. Let's move on. Any comment? Okay, you can ask at the end, or if you're too shy, I can take questions in the break as well. There are many options for feature extraction in Mathwin, and this really goes back to you, to what do you want to use. Today I only used a few of these techniques, but you can really make a lot of permutations and combinations to fit the needs of your specific problem. So with that, I think we covered the 3 challenges. Remember, handling large sets of images, I used image set. Challenge number 2, how to extract this information. Here I used the bag of words, but you can see that there are many feature extraction techniques in the computer vision system toolbox. And finally, how to model the problem using machine learning. I used the classification learner app. Okay. Something great about the app as well that I didn't mention is the fact that you can actually not only export the variable, but go right here and generate the code that you would actually have written in MATLAB. So if I click here, I just get, let's minimize this, I just get the code that I should have written. All right, so this comes in handy because, hey, look at the code. I mean, it's probably quite tough to write it from scratch in the first place. All right, and there are many other examples of object recognition. Here are a few. Today, Mathworks, we at Mathworks have well, lots of customers that use computer vision system toolbox for very many different things. But here's just a few ideas. So face recognition is very popular. Fingerprint recognition is as well. Today, well, the very high end of smartphones have fingerprint recognition techniques. Also, this is very much used in robotics. I don't know how many of you do robotics, but this is very popular there as well. Other applications of the same workflow, so detection and localization, it's pretty much the same. And I can see this as a 2-class object recognition algorithm. So basically, if I have pictures of coffee mugs and pictures where I don't have coffee mugs, I have a 2-class classification technique, which is the coffee mug present, yes or no, and where is it? And this is also used a lot in anomaly detection and verification. So for example, ceramic coffee mugs are a pass and non-ceramic coffee mugs are a fail. Some recommended next steps for you are take a look into Parallel Computing Toolbox and MATLAB Distributed Computing Server. This is very powerful techniques for handling large collections of data when we have when we need more power than what our computer initially provides to us. Also, we can use, with Parallel Computing Toolbox, we can use GPU computing so that we can take advantage of our GPUs to perform our classification techniques and our training. Also, a very popular library is Neural Network Toolbox, so you can take a look into that. And I would like to highlight that Computer Vision System Toolbox, and in general, all Mathworks toolboxes have a very extensive documentation. You probably have gone through that already. But there are many, many examples that you can explore and that do probably similar things to the applications that you need to do. Okay, let's move to other examples. Object detection with MATLAB. Here I have an image of a colleague in Mathworks. He's actually one of the computer vision system toolbox developers. And we want to figure out a way if we can detect him, we can detect the pedestrian. And also we want to find a way in which we can detect the stop signs. And there are many approaches available for this. We can use, and here are 4 of the approaches that I can see. There are probably more, but we can use a technique called feature detection, extraction, and matching. I'm not going to go through that because it will take a lot, but if you have any questions, you can come by and ask me about that. We can use some pre-trained models, and I'm going to use a pre-trained model to detect the upper body, or really the pedestrian. We can also use out-of-the-box frameworks, which basically means how about you have to recognize some other object that we haven't pre-trained, like a stop sign or like any other object. And we will look into how to create that framework. And then also, of course, you can do this from using the functions in the toolbox. You can do this basically from scratch, right? Like I did right before. So we can see, like I said earlier, object detection is classification. So in this picture, you see I have a patch of a person. We extract the features, we classify the patch, and we get a label and a score. And if I want to detect where the object is present, basically what I'm going to do is I'm going to get a fixed size patch object, and I'm going to slide it across the entire image, across also multiple let's say multiple images of different dimensions, and I'm going to compute the probability of the person being present. That's how we detect or we locate the object. And so let's move into MATLAB. Let's go into this detection technique. Okay, so very quickly, I'm just going to start by reading an input image and showing it in MATLAB. I'm going to dock this for now. All right, and here you see in line number 6, I'm going to be using a class called vision.peopleDetector. And this is a class that we have created at Mathworks that we have pre-trained for you, and we have many different of these classes already pre-trained. We have pre-trained models for upper bodies, noses, mouth, eyes, and faces, and so on. And then you can also say, like I said before, you can also create your own detectors. So with that, I'm just going to run this, and I'm going to insert a shape in the object. So as you can see, I just detected that. And the next thing I'm doing is I'm going to use one of these out-of-the-box techniques using something called a cascade object detector, assuming some of you are familiar with that. And so this is a model that I created myself, and it's already trained. I'm going to show you how I did that in a moment. And as I run it, you see that I can find the stop sign. Okay, so let's look into how I created this stop sign. And the thing is, in order to create this object, I'm going to have to get a wide range of images where stop signs are present, and basically create bounding boxes to detect where the stop sign is present. And that is a very tiring and boring step. But there's also an app that will help you do that very quickly, which is called, where is it? The Training Image Labeler app, okay? So this comes with Computer Vision System Toolbox, and it's very great because I'm going to open a session because it's going to take a while if I load all the images and start creating bounding boxes for each one of them. But you see on the left-hand side, I have all the images, and I've already gone through the process of highlighting where each of the stop signs are. But this is very easy because you can just click and create a bounding box for each one of these images. And then when you're done, you basically export the ROIs into MATLAB, and you continue working there. So I'm just going to export these positive instances. All right. So what I'm going to do now is I'm going to use a negative folder. I'm just going to run this for a moment and show you what I have in the negative folder. So I have just 5 images, which is probably not good enough, but you see that in these 5 images, I don't have any stop signs, right? And we'll look into why this is probably not a good enough data set. Okay, I create a detector file, which is basically going to store all my training. And this is going to be using a train cascade. Well, it's going to train a cascade object detector using the detector file, the positive instances that I had, the ROIs, and a negative folder with the location of the pictures where I don't have any image or any stop sign. And then once I train that, I'm going to run the detector on the image, and I'm going to create a box where a stop sign is present. So this is me just using the default parameters. And when you do that, of course, well, now I have to overwrite the XML file. This training step will take just a few seconds. Let's see the result now. All right, I think forgot to load this. All right, where's my result? Here. When you do that, you see that this is failing completely, right? It's just detecting a lot of stop signs all over the place. Why? Well, this algorithm, as I used it with the default parameters, is too biased for detecting a stop sign versus rejecting it. So it's not, I mean, it's quite straightforward, but you have to think about what you're doing. And I wasn't at the time. So what you need to do is you probably need to go through the documentation and see that there's something called the false alarm rate, which helps rejecting all these stop signs. And this is by default 0.5. So what I've done here is I've used 0.05. I just commented out so that I don't have to run it because it takes a few seconds. So I'm just gonna, you're just gonna have to believe me for the training step. But then, as I run the train detector, this would do a much better job. So this detects it correctly. So it's not just using the default parameters. Make sure you just read the doc and you can make it work for your problem. So some of the key takeaways: MATLAB apps are great for making you go fast and simplify time-consuming workflows. You can take advantage of this cascade object detector, and there are also pre-trained models that you can choose from. Now, to end with, I'd like to talk a little bit about clustering. So a very quick example on clustering, you have these a collection of images, and I want to group these images based on some sort of similarity, which is color in this case. And this data comes from two researchers in Oxford University, and Niels Beck and Sisserman. So I wanted to give attribution to that. Here's the URL where you can download this information. Now, let's quickly see this in MATLAB. All right. So right here, I use also ImageSet again to load the data set. I think these were somewhere around 600, 549 images of flowers. And I'm going to use a color feature extractor technique that I created myself. So as I open it, you see that this is basically taking an image. It's computing a mask. What the mask is doing is basically removing all the green of the image because it's probably going to bias by my classification or my clustering in this case. And then I transform this from RGB to HSV. I get only the hue data, and basically I compute the histogram for the hue data. So I'm just going to run that very quickly. I'll show you just in a second how I created the mask, which I think it's really interesting. So this is done. So if I start with one cluster, and using a technique called k-means, which is probably one of the most known algorithms in machine learning, I'm just going to start with one, which is pretty obvious. So one brings one group. I'm going to start making this bigger. So I'm just going to increment it by size of 1. So if I have 2, I get here all the yellow images, and on the right side, all the rest images. It seems like that. Let's go 3. So 3 goes like this. So I have all the yellow images, the purple images, and every other image. And that's probably better, although we only see here. Let's run this again. So in the previous example, I had 2 purple images, which is good. But the thing is, those were probably the 2 only purple images in the data set. So in this example here, I have more, I have yellow flowers, reddish flowers, maybe purple flowers, and every other flower. Let me show you very quickly how I created this, this mask. Okay, and with that, we will wrap up and finish the presentation. So how did I create this? So I wanted to create a mask that will actually take out all the green, right? So this is how I did it. I'm just going to use image set. Hold on. I'm just going to read one flower. Okay, this is what I'll do. I'm just going to read one image in the image set, and I'm going to open again another app, which is called the color thresholder. Okay, I open this. I'm going to very quickly load my image from workspace. Hit OK. It tells me which color space I decide to use. In this case, I'm going to be using HSV. And you see here I have a sample flower, and now I'm going to go just into the hue data, and very quickly I'm just going to take out all the green. All right. So this is a very nice way. Okay, I'm not just going to take all the green out because if I start taking more and more, I'm just going to take all the yellow, right? So I'm just going to take most of it. And as I'm done with that, I'm just going to go to the export section and export this as a function. So as I did that, I created my mask function with all the thresholds, which is pretty nice because I don't have to do all this logical indexing myself. So again, apps are great for simplifying workflows and make time-consuming workflows run a lot faster. We have simple interfaces for machine learning, and really the MATLAB environment is a great way to get this done. Here's some background on why using MATLAB for machine learning. Really, it's very simple in MATLAB to work with very large amount of data. Today, data becomes increasingly needed in machine learning applications and in computer vision. And even now with deep learning, assume that some of you might be familiar with that, data becomes increasingly important. The great thing about this workflow is that it not only applies to imagery or video, it also applies to other areas, signal processing, finance, robotics, and others. So yeah, with that, I would like to open it up for questions. Just point out one thing. Well, maybe you don't have the question now, but you have it later on in the day or tomorrow, 20 days from today or whatever. So you can MATLAB Answers is a great resource for that. You can also contact me. So you can contact me like with as you wish, by email or using social networks. I'm everywhere, or just right now on the break. Okay, thank you. Yeah. Thank you very much. Thank you.